Hey guys, so today we're going to be looking at a Leetcode problem that is called toSum. This is a very frequently asked question when interviewing with Amazon, Google, or Facebook for their junior software engineer or internship position. A very good problem to practice for your technical interview. So let's dive into it. So the problem is, given the array of integer nums and an integer target, we want to return the indices of two numbers such that they add up to the target. We can assume that each input will have exactly one solution, and we may not use the same element twice. We can return the answer in any order. Great. So as a rule of thumb, when the interviewer has given you the problem during the interview, what you don't want to do is dive into coding straight away. What you want to do is take a step back, think about the assumptions that you're about to make, think about the solution a little bit, and then validate those with the interviewer. For example, the interviewer could have just stopped here without giving you this last bits of information. Without knowing this bits of information, it may impact your implementation going forward. That's why it's super useful to take a step back and think through the problem a little bit more before you dive into it. It is also very helpful to come up with a couple of example input and output that will help with your implementation afterwards. So in this case, Leetcode has actually conveniently given us 3 examples of inputs and output here. So we can see in example 1, we have an array of 4 elements, 2, 7, 11, 15, and we want a target of 9. By looking at the array, we know only 2 and 7 will give us the target that we want. This is the only combination in the array itself. So we know we have to return the index of 2, which is 0, and we have to return the index of 7, which is 1. In the second example, we have 3 elements, 3, 2, and 4. We want a target of 6. We know only 2 and 4 will give us the target, so we want to return the index of 2, which is 1, and we want to return the index of 4, which is 2. In the last example, we only have 2 elements, and we want the target of 6, so we know for sure that these 2 elements to get added up together will be the target, so we just need to return their index, which is 0 and 1, and that's it. Cool. Now that we have thought through the examples, the problem, the assumptions, we can dive into the code. I'm going to be using TypeScript today, but feel free to use any programming language that you want. When it comes to the actual interview, they usually will allow you to use any programming language that you're most comfortable with anyways, so it shouldn't be a big deal. Awesome. So what I usually like to start with is to write some comments that will tell me some example inputs of nums will probably be an array of integer like 2, 7, 11, 15. That's great. And the target will probably be 9, just copying from the example on the left. So result will be 0 and 1. Awesome. So the next step that I usually like to take is to write out some comments and pseudo code while thinking out loud, so that my interviewer knows my thought process and how I come up with the solution. So cool. So my first step would be to loop through the array for each element. We want to loop through the array again. So, and if the first number from the first loop plus the second number from the second loop, which is the inner loop, is equal to the target, return the result. And I think that is actually it. I think for each element we have to loop through the array again, but here we will also have to skip if the second number is the first number. Well, we can say the second index is the first index, because we cannot use the same element twice. Awesome. So now we have a pseudocode, we have a thought process, we can start turning these into actual code. So I know for our first step, we need to loop through the array, so let's write a for loop here. So we'll call it first index is equal to 0. First index has to be less than nums. And first index plus plus. Now we have our first loop. And for our second step, we know for each element in here, we have to loop through the array again, skip the second index, skip if the second index is the first index. So cool. So we need another loop in here, but instead of the first index, we'll just call it second index, and everything else is the same. Awesome. So if the second index is equal to the first index, we know we have to skip in this case because they are the same number and we cannot use the same element twice. Cool. At this point, we can safely move on to the last step, which is if the first number from the first loop plus the second number from the second loop is equal to the target, then we can return the result. So what we want to do is we want to see, well, what is the first number here? So the first number will be the dumps, the array with the first index. That will give us the actual number itself. And conveniently, the second number will be the number in the same array but with the second index, and that will give us the second number. If we add them up together, first number plus the second number, and they are equal to the target that we want, we can basically say we found the answer. So we can return the first index and second index here. So keep in mind the answer wants index and not the actual number itself. So I think this will be fine. So let's look at our solution again. So we're looping through the array, we're looping through the array again, we're skipping if they're the same index, and we're getting the number. If they added up to the target, we can safely return the first and the second index. Looks good. So let's run it and see if we get the solution. Awesome, we got the solution. So now let's run it with example test cases, which are the test cases here, and we will run it again to see if we're good across the board. Awesome, I think we got it across the board, guys. So now we got the solution. The interviewer will probably say, congrats, you solved the problem. What is the time and space complexity of your algorithm? So what they meant really is how efficient is your algorithm and how much resource would your algorithm consume when the input size starts to increase. So for example, let's say if we're thinking about time complexity here, that just means if this array of number grows, will your algorithm start to run slower or faster or stay the same, etc. So in this case, we know we're looping through the array here. So we know if the number of elements in this array is n, we know we have to loop through it n times in the first loop. However, we also have a inner loop. So for each element, we have to loop through the array again, which means we have to loop through it n times. So if this array of numbers is 2, we have to loop through twice in the outer loop. For each element, we'll also have to loop 2 times in the inner loop. So that will give us an n times n time complexity, which is basically O of n squared. Cool. So now let's move on to space complexity. So what this means is how much resource or memory will your program consume as the input size grows. So conveniently with this implementation, we're not really storing anything, or we're not really tracking anything. We're only storing 2 numbers in the memory, and those numbers will be discarded and replaced for each new iteration of the loop. So it doesn't matter how large this number array is, these will stay the same, which means this space complexity is O of 1. So that will be our time and space complexity of this algorithm. Now at this point, the interviewer will say, great, you solved the problem. You know the time and space complexity of this solution. However, O of n squared time complexity isn't the greatest. Can you make another algorithm or improve the existing algorithm so that at the end you will get a better time complexity that is better than O of n squared? And the answer is actually yes, we can actually do that. The way we do it is to use something that is called a map. So let's try using that. So first I will do is I will delete the current solutions. So what we need to do is something that's called create a map. So a map looks like this, is an object. I like to think of them as little notebooks that can track your algorithm state as your algorithm runs. So what I want my map to look like is I wanted to have a key that is the number, and I wanted its value to be the index. So what that means is I want my map to look like 2 and 0 for the first element of the array, and I want my map to look like 7 and 1 for the second element of the array. So 2 will be the actual number, 0 will be the index of the number, and that will be my map. Initially the map will be empty, and just like always I would like to write a pseudocode or a thought process comment to explain what my thoughts are. So I know I have to loop through the program or the array again, but instead of looping through it a second time, what I can do is I can find out what number I need, so that the number plus the current element is equal to the target. So for example, if I'm at 2, I know that we want a 9, I know the number I need is 7. Same thing as if I'm at 7 and we want 9, I know the number I need will be 2. Cool. And the third step will be, well, if I know the number that I need, can I just look into the map and see if the number exists in the map? If it does, then we found the solution. Return the solution. Return the result. If it doesn't, then we will continue, but put the current element information into the map. So it helps the next iteration to find the number and to compare the number, kind of like making a small note. So this looks good. Let's try to convert this into code. First step, we'll look through the array just like always. So we'll say for first index. Oh, we'll have to say that first index is equal to 0. First, oh, not a comment. First index is less than nums.length, and first index plus plus. Awesome. So for each iteration, I want to be able to find out what number I need. So the number plus the current element is equal to the target. Well, I know what the number that I have here. So the first number is equal to nums, right? With the first index here. Awesome. And I know my second number. The number that I need is actually the target minus the first number, right? So if I'm at 2 and I know the target is 9, I know the second number I need is 7. Awesome. So let's look into the map and see if the number exists in the map. If second number in map, that just means, can I find a number of 7 in the map? If I can return the result. Return the array of first index. Remember, we still want the index, but how do we know the second number's index? Well, if you look at the way map is structured, if we find the number, then we know its value will be the index. So we can safely say map of the second number, the number that we're looking for. And that will give us the index of the second number. Great. What about when we can find it? So if we cannot find the number in this iteration, that is totally fine. We will just continue, but before we continue into the next iteration, we have to note it down. So it helps the next iteration to find the number when the map is slowly getting built. So we can say map second number is equal to the second, first index. And this shouldn't be a second number, this will be our first number. So this, before we move on to the next loop, next iteration of the loop, we'll track it down. So we'll say map first number is equal to first index. So now this looks good. Now as we go through the loop, our map will slowly get built, and whenever we hit the number that we want and we see it in the map, we will actually just return the result. And we know each input will have exactly one solution, so we know eventually it will basically hit this part and we will be able to find the solution this way. Looks good. Let's run it to see if we get the same result. And looks like we did. Awesome. So at this point, this is great. At this point, the interviewer will say, this is great. What about the time and space complexity of this algorithm? Well, remember what time complexity is. Time complexity has to do with the number, how efficient is your program when the input grow. In this case, we're only looping through the array once instead of having an inner loop. When looking up in a map, the efficiency is super fast. It's actually a O of 1 complexity. So we still have the first outer loop, which is n. And when we look into the map, which is in here, that is actually just O of 1. So we actually have O of n times 1, which is basically O of n. Great, that is better than the O of n squared. However, when we look into the space complexity here, we are actually storing more things. Remember, we're making note as we go through the array. So the worst case is the combination of the first number and the second number are at the very end of the array. So that means our map will grow in size with the number of elements in the array. So that actually gives us a O of n space complexity. Now you might say, hey, wait a minute, the time complexity is better, but the space complexity of the first implementation is O of 1. So what makes this algorithm better than the first one? The answer is, in the programming world, space complexity is usually very cheap, and what you want is a better time complexity with a little bit of sacrifice in the space complexity, then that is totally fine. Thank you for watching this video. I hope this video has helped you prepare your next technical interview. If you like the video, press the like button, leave a comment, and I'll see you guys next time.